All right, so this question reads, at a business symposium, there will be exactly 5 speakers, L, M, X, Y, and Z. Each speaker will give exactly 1 speech in either the gold room or the rose room. In each room, there will be exactly 1 speech at 1 p.m. and 1 speech at 2 p.m. In one of the rooms yet to be determined, there will also be a speech at 3 p.m. The schedule of speeches is constrained by the following. All right, so we have our inventory. We have L, M, X, Y, and Z. So we know each speaker is going to give 1 speech, so that's a 1 to 1 to 1 to 1 ratio. Now we know we have 2 rooms, the gold room and the rose room. We know there's going to be 1 speech in each of the rooms at 1 p.m. and then 1 speech in each of the rooms at 2 p.m. We also know there's 1 other speech at 3 p.m., but we don't know in which room. Now, let's go to the rules. Rule number 1. M's speech must be earlier than L's and in the same room. Okay, so we know M is before L, but in the same room. So that tells us that L can't be at 1 o'clock in the rose room or at 1 o'clock in the gold room, because then there'd be no place for M to go. Likewise, M couldn't be at 3 o'clock in either of the rooms. Now, rule number 2. Neither X's speech nor Y's speech can be earlier than Z's. So that means that Z's speech is either going to be before or at the same time as X and Y. So remember, that's a tricky one. Just because neither X's speech nor Y's speech can be earlier than Zimmerman's doesn't mean that one of them can't be at the same time. Because remember, at 1 p.m. and 2 p.m., 2 people will be speaking just in 2 different rooms. So what that does mean is that Z can't be at 3 p.m. in either of the rooms. Because if Z were at 3 p.m., there's only 1 3 p.m., meaning X and Y would not have any place to go after it. Likewise, we know that we can't have 1 p.m. be both X and Y, but there's no way really to write that out for us. But just remember that we can't have a binary of X and Y in 1 p.m. because then there'd be no place for Z to go. Because Z has to be before X and Y or at the same time as one of them and before the other one. And rule number 3. If L's speech is in the gold room, then X's and Z's speeches must both be in the rose room. Alright, so if L is in the gold room, then X is in the rose room, and Z is in the rose room. Contrapositive, X is not in the rose room, and remember, each one of the speakers will be giving a speech in one of the rooms. So if X is not in the rose room, then that means X in the gold room. Or if Z is not in the rose room, so if Z is in the gold room, then L is not in the gold room, meaning L is in the rose room. So we know that we'll always either have L in the rose room, or X and Z in the rose room, or all 3 X, Z, and L in the rose room. Alright, so there's a really cool deduction you can make here by trying to place where ML is going to go. So we know that we're either going to have a 3 p.m. slot in the gold room or in the rose room. So let's say we have our 3 p.m. slot in the gold room. So we have 1, 2, 3, 1, 2. Now we can either have ML be in the rose room or in the gold room. So let's write out both options. In the first option, we'll have ML be in the rose room because that'll just be easier. We know M is going to be first and L is going to be second because rule number 1 tells us that M's speech is before L's speech. In the second option, we still have gold room having the 3 p.m. speech. We have 1, 2, 3, 1, 2. And here, we're going to have ML in the gold room. So that gets a little bit trickier. We know that L can't be first because M is going to be first. So we're going to have ML in the gold room. Now, we know from rule number 3, if L is in the gold room, that X and Z are going to be in the rose room. And we know from rule number 2 that Z is going to be either before X and Y or at the same time. So if X and Z are going to be in the same room together, that means Z is going to be first. So we have Z and then X. And that means all we have to do is place M, L, and Y in the gold room. So since L can't be first, because rule number 1 tells us that M is going to be before L, our 1 p.m. slot in the gold room is going to be either M or Y. Likewise, M can't be 3 p.m. because M has to be before L, and if M is 3 p.m., there's nowhere for L to go. Our 3 p.m. spot's going to be either Y or L, and our 2 p.m. spot can be either M, Y, or L. Now, in our first option, we have ML in the rose room, which leaves X, Y, and Z in the gold room. And we know from rule number 2 that Z is going to be before X and Y, so that makes it easy. We know Z is going to be first, and then we have an XY binary. Now, these are the two options if the gold room has the 3 p.m. speech. Now let's write out our two options if the rose room has the 3 p.m. speech. Okay, so first let's have our ML be in the gold room. So we have M first, L second. That leaves Z, X, and Y for our rose room, and again we know Z is first. We have an XY binary so that we can abide by rule number 2. And rule number 3 is also being satisfied because we have L in the gold room and X and Z are both in the rose room. Now, in our last scenario, we have ML in the rose room here, but things are a little bit more up in the air. We have to think about what other speaker can be in the rose room. Well, we know Z has a lot of restrictions. So could Z be in the rose room with M and L? Okay, well, if we had Z in the first position, we could have X and Y in the gold room and M and L still be in the rose room. But think about Z in the second position, so for 2 p.m. in the rose room. We have Z here. We know to abide by rule number 2, X and Y have to either be at the same time or after. So that would mean that we have XY here and YX here, but now there isn't enough room for M and L to be in the same room together. So that tells us Z can't be second in this scenario, and we already know that Z can't be third because if Z is third, there's nowhere for X and Y to go. Likewise, we know, since M is before L, that L can't be 1 p.m. in the rose room, and M can't be 3 p.m. in the rose room. And if you notice, 2 p.m. in the gold room can't be M, L, or Z, so it must be either X or Y. And that's all we know in this scenario. So we have these 4 scenarios that we can use to guide us through the questions. So we have our setup, our rules, and our deductions. Let's go ahead and hit the questions.